Welcome back to LeetCode. Today, we're tackling the climbing stairs problem from LeetCode, a classic question in dynamic programming. Let's break it down step by step. Imagine you're climbing a staircase with n steps. Each time, you can either take one step or two steps. The question asks, how many unique ways can you reach the top? Let's visualize it. If n equals 2, you can either take two one-steps or one two-step. For n equals 3, there are 3 combinations. These examples help us understand the problem intuitively. To solve this, we'll use a dynamic programming approach. At each step n, the number of ways to climb is the sum of ways to climb n one steps and n two steps. This is because you can reach step n by either taking a single step from n1 or a double step from n2. This relationship is similar to the Fibonacci sequence. Let's implement the solution in Python. We will start by defining the function climbStairs, which takes an integer n as input. This represents the total number of steps in the staircase. Next, we handle the base case. If n is less than or equal to 2, the number of ways to climb is simply n. For instance, if there's one step, there's only one way to climb it. If there are 2 steps, you can climb it in either 2 single steps or 1 double step. So, in this case, we return n. If n less than or equal to 2, return n. Now, we initialize 2 variables, prev1 and prev2. Prev1 will store the number of ways to climb one step, which is 1, and prev2 will store the number of ways to climb 2 steps, which is 2. Prev1, prev2 equals 1, 2. Here's the main part of our solution. We use a for loop to iterate from step 3 to n. For each step, we calculate the current number of ways to climb by adding the previous 2 steps. For I in range open parenthesis 3, n plus 1 close parenthesis colon. Inside the loop, we calculate the current step's value. Current equals prev1 plus prev2. Current equals prev1 plus prev2. Then, we update prev1 and prev2 to move to the next step. Prev1 becomes the value of prev2, and prev2 becomes the value of current. Prev1, prev2 equals prev2, current. Finally, after the loop ends, the variable prev2 will contain the total number of ways to climb the staircase with n steps. So, we return prev2. To summarize, this code solves the climbing stairs problem using a dynamic programming approach. Instead of storing all previous results, it optimizes space by only keeping the last 2 calculations. This gives us a time complexity of O of n and a space complexity of O of 1. Now we've written the logic. Let's test it with a few examples, like n equal to 2 and n equal to 5. Here's the output for our test cases. For n equal to 2, the result is 2. Everything works as expected. That's it for the climbing stairs problem. We used dynamic programming to solve it efficiently. If you found this helpful, make sure to like, comment, and subscribe for more coding tutorials. See you in the next video.